Now let's talk about correlated subqueries. Subqueries are select queries nested inside another T-SQL statement, such as a select, insert, update, or delete, or even inside another subquery. Subqueries that can run independently are referred to as non-correlated. Here's an example of a query that includes a subquery. If you take a look at the in clause, you'll notice that nothing in that clause references anything in the outer query. It's independent. Some basics about subqueries are the following. Always enclose select subqueries in parentheses. Subqueries always return a single column. A select subquery will have its own table and column list from clause, optional where, group by, and having clauses. And unless it's used in conjunction with top, order by clauses are invalid. You'll also come to discover that compute and for browse clauses are invalid. Only columns from tables referenced in the outer query appear in the result set. End text, text, and image columns, well, they can't appear in the subquery select statement. Distinct can't appear in subqueries that also use a group by clause. And SQL Server supports up to 32 nested levels of subqueries. However, I recommend you don't get anywhere near that. So what exactly is a correlated subquery? These are subqueries that reference one or more tables and columns from the outer query. In other words, they're not independent. And they receive their values from the outer query in order to evaluate their own results. So SQL Server must execute the subquery once for every set of values it receives from the outer query. And because of this, correlated subqueries are sometimes referred to as repeating subqueries. Let's head over to SQL Server Management Studio and take a look at a couple of examples. Okay, here we are in SQL Server Management Studio, and in this example we're going to take a look at a correlated subquery. As you can see here, we're going to do some selecting from our product table, and what's going to drive that is a subquery that's part of the where clause. We are going to choose all the subcategories for which the results come back with a product subcategory whose name contains the word mountain bikes. So it'll search through all the subcategory types, and any of those categories that have the word mountain bikes in them will return a set of product subcategory IDs, because remember, subqueries only return a single column, and we will include them in our outer query if the subcategory associated with the product we're looking at matches one of those in the subquery. So let's go ahead and execute this. And we get back our rows. All of them are mountain bikes, and the subcategory was aligned with the results coming back from the subquery used in the where clause. Here's another example of a subquery. This time it's not used in a where clause, but it's used as one of the columns that's going to be returned in our select. And the object of this particular query is to go out and retrieve the current hourly rate for each of the employees. Now, because the rate is a one-to-many relationship, meaning that employees can have multiple rows for their pay rate as time goes by, we need to go out and find the current one. And so what we're going to do is right here, we're going to have this column that's going to come back that's called hourly pay rate, but we're going to do that by selecting the top one pay rate from our pay history table, and we're going to align that on the business entity ID. So that's how we're going to tie the subquery to the outer query. And we can actually get away with this order by rate change date descending, meaning get the most recent rate change first, because that'll be the top one row, that highest row, the row with their latest rate will be the first one that we encounter. And we can get away with that in a subquery in this case because we are using top. If we weren't using top, we wouldn't be able to use the order by. So it's a way of us getting away with it, so to speak. And so what will happen is we'll execute this query, and for each row, each employee that we encounter, SQL will go out and calculate the latest pay rate for each of those employees. And it does this by executing that subquery. So a couple of examples of using subqueries. So now we're going to talk some more specifics about the where clause. And the reason for that is subqueries are often found as part of a where clause. Outer queries often depend on the existence of related rows. And those outer queries often depend on columns compared to a value found in another table. We find that the where clause is a convenient way to accomplish this task. In most cases, subqueries will take one of the following forms. Where some expression is not in the result set of a subquery, where a certain condition does not exist within a subquery, or we might use some modifiers to discover whether any or all of the rows in a subquery satisfy the where expression. The not in or in syntax will return a list of 0 or more values, after which SQL Server will evaluate the outer query. And if you use an exists and not exists, a list of 0 or more values is also returned. They are equivalent semantically to their in, not in counterparts. Here's a note though. By convention, when using exists or not exists, the subquery uses a select star instead of select column name. The reason for this difference is when checking for existence or the lack thereof, SQL Server does not return any data, but rather true or false. Let's take a look at some of the modifiers available to us. Comparison operators used in conjunction with the any, some, or all modifiers affect the rows returned by a subquery. Some or any will return true when the comparison is true for at least one value in the subquery. Otherwise, it returns false. All requires that every value in the subquery be true for the comparison. And if not, SQL Server will return a false. Here's another tip. Some is the ANSI 92 equivalent for any. Using either keyword is completely acceptable, but using some makes the code more portable. What about the having clause? Subqueries can be included in the having clause of the outer query. Having clauses work in conjunction with a group by clause. SQL Server will evaluate the subquery in the having clause once for every distinct group defined by the outer query. You can actually use a subquery in an update statement, and it's quite common. A subquery used as part of the where clause limits the rows to which SQL Server applies the update. Here's an example. What if we want to reduce bicycle prices by 15% for any of those models whose current inventory level is more than twice its safety stock? Meaning, hey, we've got some extra inventory, we want to reduce prices and try to burn through it. Using a correlated subquery in an update statement is the best way to do it. Now let's go over to SQL Server Management Studio and take a look at some more subquerying examples. Okay, in this example, we're going to take a look at using the all modifier and using a subquery. And the way that this subquery works is we want to go and calculate the average list price of our bicycles by category. And once we have those average prices, we want to then in the outer query select the rows for bicycles whose list price is above all of the average list prices for each category. So we're looking for the most expensive bicycles in our inventory. And the key here is just to point out that we're using the all modifier, which means that every single row that we select here has to have a condition where the list price is greater than every row retrieved by the subquery. So if we execute this, just to show you, here are the bicycles that are extremely expensive in our inventory, and that's because they do indeed have a price that exceeds all of the average list prices for each category. In this example, we're taking a look at having a subquery as part of that having clause. So because we're using a having clause, we know that there's a group by, they work together. So what we're doing here is we're just going to return a list of customers who have purchased 50 or more items in a single order, so our best customers. And the reason that we're going to do that is we're going to calculate a potential 15% savings for volume purchasing. So what we're doing here is this is just how we're calculating a discount, right? Here is where we have the total due on their order. So taking 85% of that will show, so taking 15% of that will show what their discount could be. And here we have our normal inner join stuff, just getting all of our details together. We're taking a look at ordering between a very specific range of dates, roughly a month, between May and June of 2007. We have our group by down here, so everything so far is very normal, very straightforward. And here's where we're saying, hey, wait a minute, I have this count up here. That's going to tell me how many items they purchased in that order. And the key here is that we wanted to give this savings to those that purchased 50 or more items. So down here in the having clause, we're executing a subquery, which is simply saying, wait a minute, make sure that the count for each of the rows that we're inspecting, make sure that that count is greater than or equal to 50. And if so, then we'll include it in the result set. So a fairly sophisticated query to go and produce the results. But because we're able to use that subquery with the having clause, it's pretty straightforward to get at those results in there. And you can see here that indeed the number of items in each of their orders was greater than or equal to 50. Finally, in this query, we're taking a look at that update statement and how we can use a subquery with an update. And in this case, we're going to go ahead and reduce the bicycle pricing by 15% for those whose inventory levels are greater than twice their safety stock. So here we're going and dealing with it pretty straightforwardly. Here's the reduction. Go ahead and reduce the price by 15%, where the safety stock multiplied by 2 is less than the total number of inventory. Once we do that and make sure that our product subcategory is only applying to bicycles, we have taken the power of the subqueries and we're able to modify that price. So once again, just go out, calculate the safety stock level. The premise of the query is that we have to have more than twice that on hand, which is where this comes into play. And then we go and verify that by saying, hey, as long as the number of rows coming back in that subquery is less than that doubled safety stock, then we can reduce our prices. So if we go ahead and execute this we'll see how many rows that actually affects. And actually there are 10 products out there for which that condition is true. And just by using a couple of subqueries, we were able to adjust our pricing. So now we're going to take a look at subqueries and how they compare to joins and temp tables. Many of the subqueries can also be expressed using join syntax or by using temporary tables. But in most cases, there's little performance difference between the T-SQL code containing the subquery and those that don't. Here are some general guidelines to assist you in deciding which approach to use. Non-correlated subqueries perform better than correlated subqueries. Correlated subqueries must execute once per row, as defined by the outer query. In subqueries that check for existence, the join equivalent often performs better. If the join syntax contains aggregates such as sum, min, max, average, count, a correlated subquery may actually perform faster. So here's an example of a subquery. We're using that subquery in the in statement within the where clause, and we can rewrite that as a join, where we are joining on the subcategories between product and the subcategory table, and this actually performs much, much faster. And in fact, in this particular case, the SQL Server Optimizer doesn't even have to evaluate the subquery. It's free to choose a better execution plan if one actually exists. Another alternative is to use temporary tables. The subquery listed above can execute separately and store its result in a temporary table. And once completed, the outer query can join against that temporary table directly. But here's a warning. Be careful when working with temporary tables. The performance may suffer based on the size of the result set. You have to keep in mind that SQL Server creates those objects in TempDB, and it may actually need to write those results to disk, depending on the size of TempDB, and that'll result in extra execution time. Let's go ahead and take a look at some examples. In this example, we're taking a look at replacing a subquery with an inner join. If you remember earlier, we had an example where we were taking a look at subcategories whose name contained mountain bikes. And if we found rows whose subcategory contained the name mountain bikes, we wanted to include them. We did that through a subquery. What we're doing here is we're using an inner join to do the same thing, and these types of queries tend to perform much, much faster. So all we're doing is joining between the subcategory ID found in the product table and the subcategory ID found in the subcategory table. We're using the where clause to filter out. Only want those that contain the phrase mountain bikes. And when we execute that, we get back the same results as we did before, but actually that query runs much faster. Finally, we're taking a look at how we can use a temp table to replace the subquery. Instead of doing an inline subquery to figure out what the current pay rate is for every employee, what we're doing is simply creating a little temp table here where we take the ID of the individual and find their current pay rate by looking at their last rate change date. And we take those two pieces of information and we insert those into a temp table, this pound temp table right here. That'll create a temporary temp table in memory, throw the rows in there, each containing an ID and their last rate change date, and now we can go back here and select out our results. Only this time, rather than doing the subquery, we're joining our person table against our temporary table because we have the ID of the person and we also have their rate change date. with those two pieces of information, we can grab these results very quickly and return them back out. And so that matches what we did earlier, only a different approach. And not that I'm saying that in every case you want to do this and swap out subqueries for temp tables, but take a look at them as being an option when you get into more complex queries.